All right, so we are now on chapter 7 and looking at probability and hypothesis testing. So the topics obviously are going to be probability, hypothesis testing, single sample research, and inferential statistics. So now we're getting into some more complex uh, ways of looking at statistics. Probability is the number of ways a particular outcome event can occur divided by the total number of outcomes, the events, often presented as proportions. So for those of you who don't like uh, proportions, fractions, that's what probability is. What is probability of getting ahead when tossing a coin? Obviously, number of ways to get a head is 1. There are 2 possible outcomes, right? So heads or tails, and you got a 50% chance. How likely would it be to roll a 2 in one roll of a die? Number of ways to get a 2, number of possible outcomes. So 1 in 6, 17%. What is the probability of rolling an odd number in a single roll of a dice? So there are 3 ways to get an odd, 1, 3, and 5, and there are 6 outcomes, so 50% chance. What's the probability of rolling a single digit number in a single roll of die? 100%, because 6 out of 6. So we have a diagram, the rules of probability of coin toss outcome. So we start, first toss, we have a head or a tail. Second toss, we have a head, so a head or head tail. And the second toss after we have a tail is a tail or a tail head. And so on the second toss, we have in succession, we have a 25% chance that it could be head tail, tail head, or tail tail. A probability rule stating that the probability of a series of outcomes occurring on successive trials is the product of their individual properties when the sequence of outcomes is independent. So the tree diagram of possible birth orders for 3 children. We have girl, 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 boy, girl, boy, boy, girl, boy, girl. And then we have boy, girl, girl, boy, boy, girl. Sorry, boy, girl, boy, 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 girl, and boy, boy, boy. So there is an outcome for each one of these is 1 in 8. The addition rule, a probability rule stating that the probability of one outcome or another outcome occurring on a particular trial is the sum of their individual probabilities when the outcomes are mutually exclusive. So probability in the standard normal distribution. The standard normal distribution. So when the standard normal curve with a z of plus 1.27 is indicated, the odds of it happening are the indicated by the area underneath the curve. So at z equals plus 1.27, the curve underneath this left is the proportion of 0.10203. So 10.2%. the proportion of it happening when the z is point or -1, we are going to add half, right, to 0.34134. So we get a 0.84. So there's an 80% chance that the score is going to fall in this range. So the standard normal curve for something happening greater than -1.33 for a standard score and 1.67 for a standard score is going to be 0.04745 plus 0.09175. Okay. So I mentioned this in the first class, the null hypothesis. The null hypothesis is the hypothesis predicting that no differences exist between the groups being compared. So the statistical annotation is hypothesis H0, and that is mu0 is going to equal mu1, or mu academic program is equal to mu general population. Okay. The alternative hypothesis, the research hypothesis, this is the hypothesis that the researcher wants to support, predicting that a significant difference does exist between the groups being compared. So at that point, our HA, our alternative hypothesis, is mu1 is greater than mu2, or mu academic program is greater than mu the general population, so that there is a significant difference. One- and two-tailed hypothesis tests. One-tailed hypothesis test, directional hypothesis, an alternative hypothesis in which the researcher predicts the direction of the expected differences between the groups. So a two-tailed hypothesis is it doesn't matter which direction, you're more likely to hit this type of hypothesis, in which the researcher predicts that the group being compared differs, but does not predict the direction of the difference. It's harder to predict the direction. So because this one doesn't predict the direction, it's easier to get. So mu 0 is that mu 0 is equal to or less than, or sorry, equal to u1, or mu academic program is equal to the general population, or it's not equal to the general population. So type 1 and type 2 errors in hypothesis testing. Type 1 error is an error in hypothesis testing in which the null hypothesis is rejected when it is true. So in other words, we reject the null hypothesis and it was true. So remember, the null hypothesis says that we're predicting there is no difference between the groups and one group and another. So that's the null hypothesis. And remember, this is the one that we want to reject. Okay. So when the type 1 error happens and the null hypothesis is rejected when it was true, that is a false positive. Okay. Type 2 error is an error in hypothesis testing in which there is a failure to reject the null hypothesis when it is false. So that means we are going to not reject the false type 2 error is an error in the hypothesis testing in which there's a failure to reject the null hypothesis when it is false. Okay. So we get a false negative. So this one is a false positive, and this one is a false negative. So to look at it in this So the truth unknown to the researcher. So if this is the actual truth and we're trying to find out the truth, when the researcher's decision is the null hypothesis is true, we reject the hypothesis, we say that it's false, that's a type 1 error. Okay. And if we fail to reject, it is the correct decision. When the null hypothesis is false and we reject it, that is correct. If the truth is that, right? So when the null hypothesis is false and we fail to reject it, then that's a type 2 error. So it's important to understand type 1 and type 2 error. The null hypothesis is true, which means that there's no difference. If we reject it and say that there is a difference, then that is a false positive, a type 1 error. Okay. If the null hypothesis is false and we fail to reject it, that is a false negative. Okay. Statistical significance and errors. So statistical significance, an observed difference between two descriptive statistics, such as means, that is unlikely to have occurred by chance. Which type of error is considered more serious by researchers? Type 1 error. And that is because you've just said that something was true when it wasn't. So it's more of an error to say this one than it is to say this one. Okay. Single sample research and inferential statistics. Single group design, a research study in which there is only one group of participants. Inferential statistics, procedures for drawing out conclusions about a population based on data collected from a sample. Single sample research and parametric test, a statistical test that involves making assumptions about estimates of population characteristics or parameters. Non-parametric test, a statistical test that does not involve the use of any population parameters. So mu and omega are not needed. The underlying distribution does not have to be normal. There are different things that we can do. So parametric inferential statistics, we can use the z-test or the t-test. Non-parametric, we can use chi-square, Wilcoxian tests, and that's in chapter 10, so later on. We calculate basic probabilities, use the multiplication and addition rules, null and alternative hypotheses, 1 and 2 tail hypotheses, type 1 and type 2 errors, single group design, the performance of a sample as compared with that of the general population. And that is chapter 7. So pretty straightforward. Just understand, and you'll be able to look up these when you take the test, that like the book text says, type 1 error is the worst kind of error because that is the type of error that we're saying we're rejecting the hypothesis, the null hypothesis, and saying that something exists when it didn't. So a false positive. Right? Think of it this way. If you took a drug test and you had a false positive, you could lose your job. So usually they have to verify it and they resubmit it, and then the test comes back and it's not positive anymore. You're like, woo, thank God. But if the other type is happening, type 2 error, you give your drug test and you know that it's, excuse me, and you know that it's dirty, but it comes back clean. You're like, all right. So try to think of it in those terms. That'll probably help make a good decision. One, it was, you know that it was clean, but it came back dirty. The other, you know that it's dirty, but it came back clean. So it depends on your perspective. From your personal perspective, you know, definitely don't want type 1 error because you don't want to have a dirty drug test. On the other hand, you know, your employer probably doesn't want type 2 error. You don't want to, they don't want you to have a clean drug test when you should have had a dirty one. So hopefully that helps with type 1, type 2 error. And we'll talk more about this tomorrow if there's a question. So I look forward to seeing y'all tomorrow.